This is Professor White. Today we will talk about graphing quadratic functions. I actually marked some of these up for you. Let's get started. You have the quadratic functions in three forms: standard form, vertex form, and factored form. The standard form looks like this. Here's an example. The vertex form looks like this. Here are two examples. And the factored form will be some like that. All right? The A will determine whether or not this parabola will open up or down. And always remember, the picture of a quadratic equation is always a parabola. It will either do this or upside down. It may cut the x-axis, it may cut the x-axis that way, but nevertheless, it will be a parabola. Okay, now that I know that, let's go look at a couple of things. To graph the quadratic function, I need a couple of things. I probably need the vertex, which is that point. If it's upside down, it's that point for the vertex. Line of symmetry is this guy. Okay, it goes through the vertex. And the x-intercepts are here, and the y-intercept is here. So if you do it a little bit shifted, your x-intercepts are going to be here, and your y-intercept is going to be there. So there are a couple of things you need to graph a quadratic function. Now, let's try to find the vertex first. And I have this equation, negative x squared plus 8x minus 12. The way you find the vertex is you go and you put down your ABCs, and then you go and you calculate negative b over 2a and take f of that. In this case, negative b over 2a is negative 8 over 2 times negative 1, which is 4. You go and plug in 4 for x, you get 4. And that means it is going to go through 4, 4. And it's going to be an upside down parabola, but I don't know if it is going to do some skinny parabola or a fat parabola. We need the x-intercepts to find out. But nevertheless, we have the vertex done. Now, when you try to find the vertex in the vertex form, what do you need to do? You're going to put it in this form, and it's already in this form if you look at it. So this is going to be your h, x-coordinate of your vertex. This is going to be your k, the y-coordinate of your vertex. In this case, it's 3, 5. 3, 5 is your vertex. Here's another example. You may have a plus minus. Doesn't matter. In this case, it's negative 3 and negative 5, your vertex. So one way to remember, the y-coordinate is going to be itself, the k. So it doesn't change sign, k. It doesn't change sign. But the x-coordinate of your vertex is going to be the opposite sign. If you have a negative, this is going to be positive. If you have a positive, it's going to be the negative. So you can look at an equation in the vertex form and just see what the vertices are. Okay. Now, how do if I'm looking at the x-intercepts at this point, the x-intercepts are going to be determined based on the discriminant. Remember what the discriminant was. Here's your quadratic formula, and this is the location of your x-intercepts. Now, if this portion is positive, you're going to get two different answers, and that are real. So that means you're going to have two separate x-intercepts. If this number is 0, this is going to drop out. You're going to only have one intercept. If it is negative, you're going to have no intercept. Okay? So, let's go do a couple of problems. Let's say find x-intercepts. That's the question. X squared plus 2x plus 1. You can do this problem by factoring, but let's assume I'm using the discriminant method. You put down your ABCs. You go and calculate b squared minus 4ac. You happen to know that that's 0. If it's 0, what does it say? It's one intercept, right? One x-intercept. You go and plug it in. This is 0. Negative 2 over 2 is negative 1. So in other words, it's telling me that that x-intercept is at negative 1, and it's only 1. The only way that can happen when this is opening up is when your parabola does this. To see where your parabola is, if it's fat or skinny, you can go and find the y-intercept. And you can find the y-intercept by putting x to 0. And then you'll get 1. And you know your y-intercept, you know your x-intercept, you know it's opening up. You can draw your parabola. All right, let's do another x-intercept problem. Your a, b, c is given, so x squared plus x squared plus x minus 2. All right, so let's go and do this problem. So let's go calculate b squared minus 4ac. b squared is 4 minus 4, a is 1, and c is negative 2. You have 4 plus 2 times 4, that's 8, that's 12. Oh, sorry, I made a mistake here. b squared minus 4ac, b squared is 1. All right, here's 1. All right, 8 plus 1, that's 9. Okay, here we go. I just calculated that wrong. Okay, so let's go and put it in. X equals negative b plus minus rad b squared minus 4ac over 2a. So let's put down those numbers. Negative 1 plus minus rad 9 over 2. And that will give you two numbers. Negative 1 plus 3 over 2 or negative 1 minus 3 over 2. That's going to give you 2 over 2, which is 1. And this is going to give you a negative 4 over 2, which is negative 2. Well, my x-intercepts are at 1, 0, and negative 2, 0. All right, that makes sense. Okay, now find x-intercepts in the vertex form. Okay, there are two ways of doing this. You can use, for example, square root method, or you can just FOIL it up and then find it the way that I did it before. So let's use the square root method. X-intercept means when y is 0. So let's do that. You're going to move 4 over. Take square root. You're going to get absolute value of x minus 1. You're going to get 2. Remove the absolute value. You're going to get plus minus x minus 1. Then you're going to move that plus minus on the other side. And then move 1 on the other side. You're going to get 1 plus minus 2. That will give you 1 plus 2, which is 3. 1 minus 2, which is negative 1. Okay? 3 and negative 1. Okay? So let's do another one. X minus 1 squared plus 4. Okay, how am I going to find the x-intercept? Same way. Set y to 0. Move 4 on the other side. Now you have a square root. Okay? And square root of a negative number, that's going to be imaginary. That means what? No x-intercepts. So you can actually stop at this point. So you know your parabola is floating. Okay. How am I going to find the x-intercepts in the factored form if it's factored like that? Remember how it is. Set y to 0. And what do? You're going to set each factor to 0 to have that 0 product. That's going to give you 1. That's going to give you negative 3. So where are your x-intercepts? So that's pretty easy. It's at 1, 0, and it's at negative 3, 0. Okay, that was easy enough. So what am I doing each time I'm looking for x-intercepts? I'm setting y to 0 and find the x's. All right. Okay, I did that. So let's go and find the y-intercept in the standard form. To find the y-intercept in the standard form, what do you need to do? You need to set x to 0. So let's go and find it. So I'm going to set x to 0. What am I going to get? F of 0 is going to be 4. Guess what? My y-intercept is going to be simply the constant term. So it's going to be 0, 4. Okay, it's going to intercept y at 4. Okay. How am I going to do that y-intercept when I'm given in the vertex form? It's the same thing. You're going to go and you're going to plug in x0. So let's go do that. 2, negative 3 squared plus 1. 2, negative 3 squared, that's 9, plus 1. 2 times 9 is 18, plus 1, 19. Where's my y-intercept? My y-intercept is 0, 19. You can actually stop at any time. How am I going to find y-intercept when I have it in the factored form? Again, you're going to go x0. So you're going to go 2 times negative 3 times negative 4. So this is going to give you a positive. 2 times 3 is 6 times 4, 24. Where is it? 0, 24. All right? So you're finding y-intercept by doing what? Just setting x to 0 each time. So let's go and let's put everything together. So let's go and find the vertex. The vertex is going to be a negative b over 2a. That's going to be negative 5 over 2a. 2 times 2. So it's going to be a negative 5/4. Now I'm going to go and I'm going to take the f of that. F of negative 5/4. That's going to give me 2 times negative 5 over 4 squared plus 5 times negative 5 over 4 minus 3. That's going to give me 2 times 25 over 16. Excuse me. Minus, negative 25 over 4 minus 3. Let's do a couple of things. This is 8. So I have 25 over 8 minus, I multiply this by 2. I'm going to get 25 times 2. It's going to give me 50 over 8 minus 3. And you're going to get negative 25 over 8. Negative 3 times 8, negative 24. So you're going to get negative 49 over 8. Okay? That's my vertex. So my vertex, I'm going to do it in here. Negative 5 over 4 over negative 49 over 8. Line of symmetry. How am I going to find my line of symmetry? That's the x-coordinate of my vertex. X equals negative 5 over 4. All right. So let's go to the next step. Xintercept. What was my equation to start with? I'll rewrite that. F of x equals 2x squared plus 5x minus 3. To find the x-intercept, what do? Set y to 0. 2x squared plus 5x minus 3. And how do you do that? Let's go find b squared minus 4ac, like we were doing. B squared is 25 minus 4, a is 2, c is negative 3. That will give me 25 minus, that's plus. 2 times 4 is 8, times 3 is 24. That will give me I'm just making all these mistakes. 25 plus 24, that's 49. Okay, I'm going to go and put it in the quadratic formula. X is negative b plus minus rad 49 over 2a. Okay, that's going to give me two answers. Negative 5 plus 7 over 4. Negative 5 minus 7 over 4. That's going to give me 2 over 4, which is 1/2. And this is going to give me negative 12 over 4, which is negative 3. Okay, my x-intercept is at 1/2, 0, and it's at negative 3, 0. Okay, well, let's go and let's find the y-intercept. How do I find the y-intercept? I set x to 0 in my original equation. F of 0 is going to be negative 3. So it's going to go over 0 and negative 3. All right. So can I go and put all this together? So I'm going to rewrite vertex for this guy. F of x equals 2x squared plus 5x minus 3. My vertex was at negative 5/4, negative 49 over 8. My x-intercepts, I'm just copying it from the previous page, 1/2 and negative 3. And my y-intercept is 0, negative 3. And my axis of symmetry is when x is 1/2. And since this is positive, it's going to open up. Okay, well, let's try it. Vertex is kind of hard, so I'm going to do with the x-intercept. 1/2, 0. 1/2. And negative 3. 1, 2, 3. It has to go through the here. Y-intercept is 0, negative 3. All right. And then negative 5/4, that's like negative 1 and 1/4 around here. And then negative 49 over 8, that is like 6 times 8 around there, negative 6. 1, 2, 3, 4, 5, 6 around there someplace. Okay. Okay, my line of symmetry. Oh, what did I write in here? What was I thinking? For my line of symmetry, that's the x-coordinate of my vertex, and that's going to be negative 5/4. All right, so let's put all that together. So it needs to be around here. It needs to go through here and through here. Here we go. Here's my parabola. Okay. You don't need all these to actually draw it. But let's do the same thing with the vertex form. So let's do that. Vertex is going to go through here. So that one is a little easier. I just look at it. line of symmetry, that's my x-coordinate of my vertex. And that is going to be x equals 1. All right. Let's go to the next stage. X-intercept. Let's put down the equation. The equation was f of x equals x minus 1 squared plus 2. And x-intercept, that's when y is 0. So x minus 1 squared plus 2 is 0. Move x minus 1 squared over negative 2. Oh, this is negative. I cannot take the square root. So no x-intercept. Okay, how is y-intercept going to go? That's x equals 0. Put 0 in here. So you have negative 1 squared plus 2. That's going to be 1 plus 2, which is 3. That's going to be 0, 3. All right. Let's go and try to draw this. I'm going to rewrite it right here. According to my notes, the vertex is at 1, 2. 1, 2. It will open up because this number is positive. The x-intercept is no x-intercept, and y-intercept is 3. 1, 2, 3. It has to go through here. Here's my line of symmetry. So that means it has to be here on the other side because of the symmetry. And it opens up. Here you go. Okay, so this one was a little bit easier than the previous one. Let's do putting it all together in the factored form. Vertex. Well, I can do this as negative b over 2a, but I kind of know how this one looks like, but I'll just open it up. For the vertex, FOIL it out, x squared minus 2x plus 1. Okay, negative b over 2a is going to be negative b is negative 2 over 2a is 2. So that will give me 1. And then f of 1 is going to be, put 1 in there, 0. My vertex is going to be 1, comma 0. Line of symmetry, x-coordinate of my vertex, so that's going to be x equals 1. Okay, the x-intercept, that's going to be when y is 0. And that means x minus 1 is 0. That means x is 1. My x-intercept is 1, 0, which is the same as the vertex. Y-intercept is when x is 0. Put 0 for x. So you're going to go negative 1 times negative 1. That's going to give you 1. So let's put it all together. My vertex is at 1, 0, 1, 0. It will open up. Line of symmetry is that x equals 1. Y-intercept is x equals 0, y equals 1. It has to go through here. And the only way, and x-intercept is 1, 0, and this is the only way it can happen. All right. Okay, I also wanted to do one more thing. The completing the square steps. If you want to, you have it in the standard form. For some reason, somebody's asking you, please don't work in the standard form. Just put it in the vertex form. I'm going to show you how to complete the squares. This is actually in another video as well. But I'll just do it here as well. Instead of using the negative b over 2a, if you want to put it in the vertex form, this is what you do. Okay, so you're going to look at this part only. Ignore the constant term. And you're going to complete the squares in here. So you have your constant term in here. Just put it away for now. Then you're going to go and you're going to do your thing. So to complete the square, what do I need? X squared plus 2x. I need a 1. Divide 2 by 2, that's 1. 1 squared is 1. But I cannot just put that 1 in there, because I feel like it. I have to put a 1, and I have to subtract the 1. Does it make sense? So you have this, x squared plus 2x plus 1 minus 1, and you had a negative 5. Guess what? This is x plus 1 squared, and this is negative 6. And guess what? Now you have it in the vertex form, and you can actually write the vertex right away. The vertex is at negative 1, negative 6. Okay? I would not do that unless I'm specifically asked to do it, because it's a lot of work. So I can actually go and do negative b over 2a to find the vertex.